Hello, I'm going to share some new information about the Saros Cycle. These are some new insights that I've gotten over the past week, and they're mostly insights into the astronomy of the Saros Cycle that do have implications for interpretation. So some interesting details about what goes on with the Saros Cycle. So I will review what the Saros Cycle is and then share with you some of these new insights. So what is the Saros Cycle? Here is an explanation from a NASA website, and it says the periodicity and recurrence of eclipses is governed by the Saros Cycle. Okay, so the Saros Cycle is a pattern. It's a repeating pattern that happens with the Saros Cycle. And this periodicity, this rhythm, this beat of the eclipses happens every 18 years, 11 days, and 8 hours. So if there is an eclipse today, then 18 years, 11 days, and 8 hours later, there will be another eclipse that's similar to the one you're having today. And this series of eclipses, every 18 years, 11 days, and 8 hours, it goes on for over 1,000 years. So it has a beginning and it has an ending. There are about typically 72 of these eclipses that are extremely similar. So it's very interesting. It has a birth. It lives for over 1,000 years. It goes on about 72 times, and then it ends. A series of eclipses that are very similar to each other. And interestingly, the Saros Cycle was known all the way back in ancient times. So it was known to the Chaldeans as a period when lunar eclipses seem to repeat themselves. But it's applicable to solar eclipses as well. So there's a Saros Cycle of lunar eclipses and there's a Saros Cycle of solar eclipses. We're going to focus on the Saros Cycle of solar eclipses in this lecture. Okay, here's a little more detail about what is this similarity? What happens every 18 years, 11 days, and 8 hours that makes these eclipses similar? Well, let me tell you what the basis of it is. The basis of it is primarily that the synodic month from new moon to new moon, or you can look at it as full moon to full moon if you want to. That synodic month, now the synodic month is what determines the distance, not the distance, the time, the duration from one eclipse to another, because an eclipse, we're going to focus on solar eclipses here, but a lot of what I'm saying applies to lunar eclipses as well. A solar eclipse occurs at new moon. It's a special kind of new moon. So the number of days between one solar eclipse and potentially another one would be 29.530589 days. This first line of data that I have here, 29 days, 12 hours, 44 minutes, and 3 seconds. Now, actually, it varies, but that's, like a typical average number of days between new moons. And some of those new moons will be eclipses. Most of them are not, but a few of them are. Excuse me. Now, what about a draconic month? The time from that the moon is conjunct the north node to about a month later when it's conjunct the north node again, because the north node of the moon is involved in eclipses. An eclipse only occurs when the new moon is near the north node or south node. So that moon to node cycle is related to eclipses. Now, it happens to be very close, but not the same as what's called an anomalistic month. It's 27.212221 days. And, I've got all the details up there, 27 days, 5 hours, 5 minutes, 36 seconds on average. That's a draconic month. Now, here's what happens. Go down to these last 3 lines, and let's just look at the first 2. the synodic months and the draconic months synchronize. They come together every 6,585 days and about 8 hours. There are 223 synodic months will occur when there are 242 draconic months within 1 hour of each other. It's like not quite, but almost exactly synchronized. Well, that 6,585.3 days is, if you convert it to years, is the 18 years, 11 days, and 8 hours. So these two, the synodic month and the draconic month, those are the primary two. Those two synchronize, and they make the eclipses very similar to each other. Because when does an eclipse occur? It occurs, a solar eclipse. It occurs at new moon. That's really the synodic month. And it occurs when that new moon is near the north node or south node, and that node returns back. It's like the same nodal cycle comes back with the new moon in that cycle, and it makes them very similar. And then on top of that, this is, to me, not as critically important, but adds to the similarity, is that the anomalistic month is from perigee to perigee. You can also call it apogee to apogee. And to make clear what perigee and apogee are, I have a little diagram here in the lower right corner. And this is for perihelion, aphelion, for the Earth going around the Sun. It's exactly the same for any object going around anything. So this diagram also applies to the moon going around the Earth, where if instead of the sun here in this yellow dot, that would be the Earth, and this egg shape we call an ellipse would be the moon going around it. And when the moon on the left is closest to the Earth, we call that perigee. G-E-E is like Gaia, is like means Earth, helio means sun. So if it's a planet going around the sun, it's perihelion, closest point to the sun, and ap means away, away from the sun. So you have a closest point in the orbit and farthest point in the orbit. So that's the way orbits look. And interestingly, there are 239 anomalistic months in almost the same beat. It's a little bit off. It's not quite as synchronized as the synodic and draconic. You know, they're both within a half hour of being 11 years. I mean, I keep saying that wrong. 18 years, 11 days, and 8 hours. And the anomalistic month a little bit off because it's 12 hours instead of close to 8 hours, but almost also synchronized means that the moon returns to about the same distance from the Earth. So here's what's happening with the Saros cycle. What's happening is every 18 years, 11 days, and 8 hours, there is an eclipse with the same kind of node. The node has come back to its same relationship to the sun and moon, so the eclipse is going to be extremely similar. If it's a total eclipse, it's going to be very, very similar. Plus the distance of the moon from the Earth is about the same. So it's a remarkably similar eclipse, known all the way back to ancient times. Very fascinating to astronomers as well as astrologers. And we can think of it as a beat, as a rhythm, that these eclipses are synchronized and have a lifespan. It's like a little drum beat that happens, lasting over 1,000 years and beating every 18 years, 11 days, and 8 hours, coming back again. Boom, 18 years, 11 days, and 8 hours again. Boom, coming back like a little beat going on in the sky. The eclipse is synchronizing like that, with extremely similar characteristics. So that's what it is. That's why it's fascinating. That's why it's interesting. And there are a lot of little interesting details about the Saros cycle that I'm going to get into. And I'm going to present some totally new things that I noticed that I don't think have ever been discussed before in exactly the way I'm going to present them, as well as some ideas that are not well known but not completely new. Okay, a little more interesting information from the NASA website. Any two eclipses separated by one Saros cycle share very similar geometries. Okay, so what he's talking about here again is the two eclipses that are separated by the 18 years, 11 days, and 8 hours. This is just giving, like a quote from an authoritative source of what I just said. They occur at the same node with the moon at nearly the same distance from Earth at the same time of year. In other words, it's 18 years, 11 days. Well, that's roughly the same time of year. In other words, it's the same season, only 11 days later. It's not exactly like the birthday of the eclipse. It's 11 days later. It's occurring at a similar time of year, but shifted over, by the 11 days and 8 hours. The moon has a similar distance from the Earth. Remember, that distance from the Earth is where the moon is in this egg-shaped, in this elliptical path. The moon has come back to the same place. The nodes have come back to the same place. And in bold at the bottom, I put it into astrological language that the sun-moon conjunction and the moon's nodes move forward about 11 degrees in the next eclipse. So when you look at two eclipses in the Saros cycle, look at two consecutive ones. They'll be separated again by the 18 years, 11 days, and 8 hours. You look at those two eclipses, what are you going to notice? You'll notice that the sun-moon conjunction, that eclipse point, has moved ahead 11 degrees, right? Because in 11 days, 8 hours, the sun will move about 11 degrees. It'll be about 11 degrees forward that it's moved in the zodiac. And where will the moon's nodes be? They will also move 11 degrees. So the nodes, the moon's nodes, and the eclipse point, they both move forward about 11 degrees. And the true Lilith position, as we call it in astrology, in astronomy, they would just call it the apogee of the moon, they would call it the osculating apogee of the moon. They don't call it true, they call it osculating. We don't need to get into exactly why. I will discuss that. That's also an interesting thing, what the Lilith position actually is, but that's another topic. We'll get to that in a separate video. So it's the apogee of the moon. It moves forward 13 to 15 degrees, a little bit more. And the reason it's a little bit more, if I go back, it's because it's not synchronized as perfectly as the synodic months and draconic months. It's taking, an additional 12, almost 13 hours instead of about 8 hours. And it's moved slightly farther, which means that the distance of the moon from the Earth has changed a little bit, but not dramatically from where it was. I mean, just the synchronization of the nodes with the eclipse, that's alone is impressive. That the anomalistic month, and therefore the distance of the moon from the Earth, is also very close, reinforces how similar these consecutive eclipses every 18 years, 11 days, and 8 hours, how very similar they are. Now, I said there are about 72. Actually, just to go over, I'm going to go over some of the facts of the Saros cycle, what it is, and what actually really happens. To be precise, there are between 69 and 87 eclipses in a Saros cycle. There are usually 70 to 73. It's very rare for it to go down to 69. And sometimes it goes way, way more than that range. But it's like, I think about 90% of the time or so, between 70 and 73. And the most common number is 72. And if you multiply that out, you'll find, if you multiply 18 years, 11 days, and 8 hours times 72, you'll find that it comes out to 1,280. So the life of a Saros cycle is between 1,226 years and 1,551 years, with the average being closer to the lower number, 1,280 years. You don't need to memorize these numbers, but you can just say, how long is a Saros cycle? About 1,300 years. I mean, for common discussion, about 1,300 years. So, suppose there's an eclipse today or tomorrow or whenever. It will be part of a Saros cycle. There's about 3 or 4 new Saros cycles every year that start up, and it could be the very first one, it could be the last one, it could be in the middle, it'll be somewhere in this, we'll call it 1,300 year cycle. Now, because the number of eclipses varies from 69 to 87, you might have an even number of eclipses, you might have an odd number. Now, if you have an even number, then there's no eclipse in the middle, obviously, right? I mean, if I have 6 tomatoes and I put them on a shelf, there's no tomato in the middle, right? You need an odd number to have one in the middle. What's interesting is that if you have an even number of eclipses, you know what'll be in the middle? A lunar eclipse. That's pretty interesting. And I learned this from Alexander M. Zaragich, who just wrote a fantastic book called Dragons of Solar Eclipses. So I want to credit Alexander for some of these details because it's in his book that I learned about specifically 69 to 87 eclipses, how many years that is, and the idea that when there's an even number of eclipses, there's a lunar eclipse in the middle. Whoa, I think that's very, very interesting. I hadn't thought of it before. I had not noticed it before. And Alexander is proposing that makes a different kind of Saros cycle. So whether the Saros cycle has an odd number or an even number will change the character of the eclipse. Because if there's an even number, you have a lunar eclipse, you might say it's a more the whole cycle will be characterized by the nature of the series of eclipses. One of the first people to get into this was Bernadette Brady, and she said that the first eclipse in the Saros cycle defines the nature of the whole series. So it's a fascinating idea that there's this reaching back into history. It's almost like going back into past lives or past connections, a connectedness, a kind of thread that lasts about 1,300 years, connecting these points in time. Now that's also what an astronomer would say. An astronomer would say the same thing. They're connecting these points in time. It's just that astrologers would give it more meaning, affecting our lives or history in some way. But just the physical fact of it, not even of the Saros cycle, and the way it works is so fascinating in itself. Fascinates astronomers even without any implications of affecting human life. So, and by the way, in the Sirius software, you can select consecutive eclipses. So you can select all the charts, like all, say there's 72 in a series, you can bring them all up very, very easily and quickly. And also, when there's an eclipse, a solar eclipse, as you probably know, the solar eclipse is only visible in certain places. And there will be an exact place, an exact latitude and longitude on the Earth where the eclipse is the most perfect. If it's a total eclipse, those pictures of eclipses that you see where the moon is like smack right in the middle of the sun. To get that perfect image, you have to be at the right place, a specific place, at the right moment to get it perfectly aligned. Because if you're a little bit away, it won't look total. If you're far enough away, you won't see it. You have to be lined up at the right place. And so some astronomers, especially ones that are deep into, really like photographers, they'll travel 3,000-4,000 miles, whatever it takes or more, to go to where the eclipse will be, and hope it's not cloudy. I mean, there's funny stories they're funny in retrospect, not funny at the time. Of astronomers taking these or astronomy enthusiasts, and photographers, traveling long distances and getting there, and, it rains all day and you really can't see anything. So anyway, you hope for the best, and, some people try to get to, hope there's like a mountaintop or, extremely dry weather, and you get these fantastic images that you can get. My point here is that there's a certain spot where the maximum eclipse is. And let me show you how you do this in the Sirius software. Is that if I go to, let me see, I didn't pull this in where I should. Okay, there, you see this better. If I go to new, add new natal chart, and then over here, this button, lunations and eclipses, and then there's various things you can select, and I select the first one in this pop-up menu, lunations and eclipses, and then I select solar eclipses, and then down here it says solar eclipse only and lunar eclipse only with more than one eclipse. Select eclipses in Saros Cycle, and I select yes. Succeeding eclipses would mean whatever date I have in here, it'll find the eclipse, and if I put 72, for example, it will find the nearest solar eclipse on the date I have here and the next 71, like 72 in a row. And if you could just, and then when you pull up the chart, it will tell you, let me see, is there anything else? One more thing I want to show you here. See this checkbox? Use place of maximum eclipse. If this is not checked, you enter a location. You could type Chicago or London, whatever you want, and if you click this, it'll create the eclipse chart for where the maximum eclipse is. So this is so totally cool, because what happens is I ran this for an entire Saros cycle. I'll tell you a little bit more about what it is, but I was interested in my own chart. Aren't we very often that way in astrology? Because we know our lives. So I did it for me. This is the eclipse right before I was born. I was born on May 1st, 1949. So about 3 days before I was born. I was born with the moon was 37 degrees ahead of the sun when I was born. So about 3 days before I was born, 2.5 to 3 days before I was born, was the new moon. It happened to be a partial solar eclipse. And it's Saros Cycle 147. So each Saros cycle is given a number by astronomers, and it says number 19. It's the 19th one out of about 72, somewhere between 69 and 87. It's the 19th solar eclipse in that cycle. So it tells me that, which is very nice to know. And I set it to place of maximum eclipse, and the place to see this eclipse, as best as it can be seen, would be at almost 62 north and almost 56 west, wherever that is, up in Canada or Greenland or wherever it is. So that would be where probably Greenland, wherever it is. Anyway, we're not concerned about that here. That's where the eclipse is maximum. Okay. All right, let's go back to our PowerPoint. And what we're doing here is we're just learning the nature of the Saros cycle. So far, I'm covering things that are mostly known, although thanks to Alexander's new book, we got specific details here. So when you do this, you bring up this eclipse chart. Well, now I know that this one before birth was the 19th one. I can go back and back and back, and I will find out that if I can then select the 19 before it. Remember in this, let me show you, in this add new natal chart, go to lunations and eclipses, I can select the preceding eclipses over here. So now that I know I'm the 19th one, the one that I was born on was the 19th one, I can put in the date, April 28th, 1949, ask for the 18, or if I want 19, whatever, preceding eclipses, and then I will get them. Now I'll know the date of the first one, and I can do all of them. So you can get the entire Saros Cycle charts here. There's also other places in software where you can see the dates and other things. But anyway, then you see the charts. And this is the feature I used to make the observations I'm going to show you next. Okay, let's go back to our PowerPoint. Okay, so I did this starting in October 1624, and I looked at each chart. So what I was interested in is the latitude of the eclipse. Where? I just showed you that the eclipse 3 days before I was born was up at wherever it was. Let's pull up the wheel, 62 north or something. Let me pull up solar eclipse for April 28th. This is alphabetical. Solar eclipse, April 28th, 1949. This is the one before birth, and it's at the place of maximum eclipse, 62 north. Okay, so what it says in the books, like if you go to that NASA.gov website or any book, astronomy book about eclipses or articles, what they say in the books is that the eclipse starts near the North Pole, the very first one. So the very first one in this series, by the way, I'll show you, if I uncheck the sort, then it has them in date order. I uncheck sort because it's calculated these in order. Here's the very first one, October 12th, 1624. And let me pull up a larger wheel. What do I want here? I want a large wheel. Yeah, something like that. I've changed this to local space. I'll tell you why. Let me go back to a normal chart. So here is the first eclipse. Saros Cycle 147. This is the cycle that I was born in, you might say. The one that was before my birth, 3 days before. The very first one, the one that astrologers have been suggesting creates the personality of this series, was on October 12th, 1624. That's using the New Style calendar. Series always uses a New Style calendar. And it was maximum way up at 70, almost 72 north. It's like, above the Arctic Circle is where we could best view this. And it was a partial eclipse. Okay, so what we have, getting back to our PowerPoint, is that when you read the books, they tell you that the first eclipse starts at the North Pole, and the last eclipse, 1300 years, will be at the South Pole or vice versa. They will start at one pole, and each eclipse will be a little bit close, will move. And I wanted to see if it was true. And the other thing that they say is that each eclipse will occur about 120 degrees west. Okay, let me review this, and then we're going to take a break and pick up with this with the next video in this series. We're going to have a series of videos on the Saros Cycle. But let me summarize what I've said so far. We'll pick up with this. Is that each succeeding eclipse in the Saros Cycle, the one that happens 18 years, 11 days, and 8 hours later, will occur at a similar latitude. So here I'm showing in this astromap 4 consecutive eclipses, and notice they're all happening at about the same latitude, extremely far north. So they occur at the same latitude, and they occur 1/3 around the world. Well, what I'm going to do in the next video in this series on the Saros Cycle is I'm going to look at this more closely. Do the eclipses start around 90 north and then just move gradually, like every degree or 2 degrees, and just like, is it beautifully, just does it speed up, slow down? I just want to know what exactly is happening with the nature of the Saros Cycle. And we're going to learn more about vibrations in the Saros Cycle. Let's just explore what's going on in a little more detail. Okay, I'll pick up with this in the next video in this series. Thank you very much for listening, my friends. God bless. Namaste.